Okay, cool. So everyone can see my screen? Yes? Good?
Yep.
Yep, awesome. Thank you. Whoever that was, just vocally acknowledged me. Really appreciate it. Okay, cool. So yeah, when we talk about scope, there's quite a few kind of distinctions around it, and hopefully you'll kind of see that even though we divide them in different ways, fundamentally they're actually all very similar. So what is scope? The book definition is scope refers to which variables can be accessed by your code at a specific location in your code. One of the things that you're going to see very quite often in programming is we actually like to segment things off very kind of in part and parcel, right? We like writing functions, we like writing loops. In fact, all the things that we've been doing so far in this class in terms of writing code and laying it out has been trying to divide the code into smaller and more easy to consume or more easy to understand portions. And that's a comment that you'll see a lot in programming, and it also amplifies the usage and the power of scope. So here, sorry, on line 4, I have this variable called wow, and it's set equal to the string wow. And on line 5, I console log out wow, and indeed, I see the word wow print out, right? This looks pretty straightforward to all of us. And when we look at this initially, we kind of might just take for granted, like, of course this works, right? Why wouldn't it work? Now, if I was to do this in a different way, right? One of the things that we can kind of start off when we think about scope is this idea of a global scope. What global scope means is the global scope refers to this idea that it's uh, it's almost like a scope that exists, that whatever variable you put in that scope is going to be called a global variable. More specifically, if you think about scope as a location, then we can think about the global scope as basically a location where anything you put on it, it can be accessed by any other location in your code. So one of the things that's actually kind of that's a very interesting kind of phenomenon that we see in JavaScript is this idea with scope, at least, is that whenever JavaScript looks at the code on your page, it actually goes through it twice. And we'll talk about what this twice over. It's called hoisting. We'll cover in one of the later slides. But really, like what this idea of the global scope actually enables us to do is saying, hey, look, scope is something that we build out layer upon layer, but the global scope is actually just kind of the outermost layer or the outermost shell. And so if we have the outermost shell and I put a variable on this outermost global scope, then it means everywhere else in my code I will be able to access it or I will be able to use that variable. So this might seem confusing right now, but you'll kind of as I go through the as I go through more and more context around local scopes, you begin to see kind of why global scope is really powerful, and also why it's also really dangerous in a lot of cases. Okay, so here on this page, all we're trying to help you kind of understand or really see here is just the fact that on line 7 there, I have this variable called wait for it. I set it equal to the string here I am. And even though this variable wait for it exists on both line 5 before I declare the variable, as well as on line 9 after I declare the variable, just notice that 1, wait for it is available in both locations in some way, and that 2, the value for it is actually not finalized or it's not given or assigned until after the variable itself is assigned the value of here I am. Okay, so this idea of a global scope doesn't really make much sense in isolation if that was all that existed, right? If I was to say, hey, here's a scope and anything I put on it is available to everyone else, well, it really kind of begs the question, why do we have scope? And that kind of brings us to this idea here that oh, sorry, let me just make sure that this is recording still. Great. Okay. That really brings us to the idea here of this idea that in contrast to this idea of a global scope, we actually have something called a local scope. And so, what is a local scope? A local scope is something that we've been creating really since the beginning of programming, right? And the easiest way to determine whether or not something is in a local scope is by looking for the curly braces. Sorry, I'm trying to get over a slight cough right now. So at the end of line 5, we see that there's an open curly brace, and on line 8, we see the closed curly brace, right? And so those curly braces designate the beginning and the end of a function. And more specifically and more importantly, really, they also designate the beginning and the end of the happy function scope. Okay, so what does scope mean in this context now? Well, if we think about scope as saying hey, everything that's created within this scope is available everywhere else. Well, here what we have is inside the happy function scope, so between lines 5 through 8. On line 6, we have us create this variable called message that says that we set equal to the value I am so happy, and we console log out message on line 7. And on line 10, I can run the function happy message, but on line 11, when I also try to console log out the variable message, you'll notice that I actually get an error on the top right hand corner of my screen. Okay. So one analogy that people sometimes give for this idea of a scope is you can think of scope as almost a sandbox, right? Everything that exists inside the sandbox is yours and can be used, but only within the confines of the sandbox. And so in this analogy, in this case, the variable message is being created within the happy function scope on line 6, and that just means that the variable message can only be used within the happy function scope, right? So it can only be used between lines 5 through 8. And indeed on line 11, because I am outside of the happy function scope, when I try console logging out message, I get an error. And not just any error, I get a reference error. And what that reference error is telling me is saying, hey, this variable does not exist, right? And the reason for that is, once again, is because notice how on line 11, that console log line, that exists outside of the happy function scope. And so if you look at line 3 there, one of the things just be note about JavaScript and variable declaration is that variables cannot be used outside of the function in which they are created, right? Basically what that means is when a variable is created, we're also creating the sandbox around that variable that determines where that particular variable can be used. And so once again, for the message variable on line 6 there, that can only be used between lines 5 through 8 and not outside of that function, which is why line 11 throws us an error message. So now that we have a little bit more context around this idea of a local scope, let's go back to the idea of a global scope now, right? On line 3, I have this variable called message, and we set it equal to think globally. On line 5, I have this variable called logs a message, and I set it, and in it I created this variable called message, and I set it equal to act locally. And on line 9, I have a console log line that says console log out message for me. The question now becomes which version of message is the JavaScript we're going to use? And the answer is JavaScript will always try to look for the closest instance of that variable first. And what do I mean by closest? It means it will look in its own scope first, and then it will look gradually more and more outwards. So another analogy that actually I'll hold this analogy for the next slide. But just note that when a variable is defined both locally and globally, JavaScript will always default to using the local variable first, or it will always default to looking for the local variable first if it exists. If it doesn't exist, then it will look for the global variable. The really kind of the core thing that we need to kind of just be clear on with regards to scope is that when JavaScript, we talk about scope and looking for variables, the idea is we are always looking in our own scope first, right? Wherever we're trying to use a variable, we are looking in that scope first. If that scope doesn't have it, we will look outside of that scope somewhere else, right? In this case, because the variable message on line 9 does exist on line 6, that's what we use. But if I, for example, have something else like this now, right? On line 3, I still create my variable called message, but on line 6, I create a variable called MSG, and on line 10, I console log out the variable message. In this case, JavaScript will say, it will get to line 10 and it will say, hey, I see you're trying to print out message. Let me look at what the value of message is. It will look at its own scope first, which is between lines 5 through 11 in the logs and message function, and it's not going to find it. And so when that happens, that's when it says, let me look now outside of your scope. And in this case, if it looks outside of the scope, it actually finds the variable message having been created on line 3, and so that's what the value that it uses. So all this means is that whenever there's multiple variables with the same name that's being created in JavaScript, at every single juncture when JavaScript reads a piece of code, there's a very, very clear order in which it will say, I will look here for the variable first, then here, then here, then here, etc., all the way until the very end. And hopefully this also makes the idea of a global scope a little bit more clear, because notice how MSG, right, is a variable that's local to the scope that was created in, which is between lines 5 through 11. Message, on the other hand, on line 3, there's no curly brace there's no curly brace around it. There's no function around it, and that just means that it is existing at the kind of the highest level of the page. And so when something exists at the highest level of the page, it just means no matter where you are on this page, if you're trying to use that variable, eventually, if that variable is not redefined somewhere else, JavaScript will eventually find that variable. And so this just means that no matter where we are on the page, I will always be able to access a version of the message variable. Okay. Sorry, before I move on to this page, just one last thing to note is that you know how we talked about how when JavaScript looks for a variable, it looks for it with its own local scope first, then the outside scope, then the outside scope of that, then the outside scope of that. What it does not do is it does not look inside the scope of anything else that it's not a part of, right? And so if I go back to the previous examples here, notice how we're going back to this example here now. Inside happy function, I create this variable called message. On line 11, when I try to console log out message, that console log out message on line 11, that line of code exists on the global scope. And so all that means is that when JavaScript reaches that line and looks for the variable called message, it can only look on the global scope. It cannot look inside the scope of anything else that's not a part of. And so in this case, on line 11, it's not a part of the happy function scope, so it can't look inside the happy function scope. And that's the reason why it says, hey, I looked on the global scope, I wasn't able to find a variable called message, and hence here's your reference error. Was there a question?
So David,
Yep.
on page 4, going back to page 4.
Yep.
So down below there was a log a message.
Yep, here or next one?
Page 4.
I can't see page numbers when I'm presenting.
Oh, I see. So the one that has I think it's prior to this page.
Okay, this one?
Yeah, this one.
Yep.
Oh, well, actually, it disappeared. There was a page where down below there was a log a message and then parens.
Here?
There, this one.
Yep.
What is line 12 doing?
Oh, so yeah, so good question. So if I'm a computer and I'm going through this line of code, right? Lines 1 through 2, there's nothing written there. On line 3, I created this variable called message. On line 4, nothing there. Lines 5 through 10, I actually skip. The first time I read this, I read through this code, because essentially what lines 5 through 10 is doing is it's creating a function, but I'm not using it yet. I get to line 12, and line 12 is where I actually invoke or actually call that function. And so line 12 is invoking the logs and message function. And so now in order to execute line 12, I then need to go back to line 5 and actually try to figure out what's going on inside this logs and message function.
So the act locally doesn't happen because of line 9. It actually happens because of line 12.
Right, yeah. In fact, line 6 and 9 both happen because of line 12. So this actually brings up a very key distinction. It's just that creating a function is not the same as calling a function. On the first pass through, when we look at lines 5 through 10, all we're doing is creating a function logs a message, right? Line 12 is when we're actually using that message. So when you think about it, it's almost like, on lines 5 through 10, it's like us like buying a car or getting a car, right? Line 12 is us actually driving that car or using that car, right? Like buying a computer or buying whatever it is, like us creating it doesn't mean it doesn't right? It just if I buy a computer, it just sits on my desk, right? If no one's using it. However, on line 12, when I actually invoke that function, or my previous when I actually open up the computer and start typing on it, that's when it actually starts doing things. And so just make sure that we don't confuse creating a function with invoking a function. The only way in JavaScript to invoke a function is with the open and close parentheses. And so if you see a function that's not that hasn't been invoked yet with the open and close parentheses, then that means that function has been created, but it hasn't been run yet. Cool. Yeah. So yeah, and actually, let me just pause a little bit longer. Is there any kind of questions around this idea of local scope versus global scope? And I guess more importantly, is it clear to everyone that when we talk about local scope, it's the idea that let me see where I am first. Let me look for the nearest set of curly braces, and then and I kind of gradually move more and more outwards as I look for more and more places where the variable could be. Whereas global scope just means, hey, it's the highest, most outermost level, and so anywhere on the code, we should be able to access that particular variable. Is there any questions on that? Cool. Well, if there are no questions, then the rest of this is actually going to be pretty straightforward, right? Because now we're just going to talk about the kind of the finer details. So one of the things that people see very often but don't kind of realize is that parameters are actually also variables. As silly as that kind of sounds, or maybe as obvious as that sounds to say, right? So on line 5 there, so actually, and just kind of be clear, we go to line 3, we create this variable called message. We skip lines 5 through 8 because we're creating a function called logs a message, but we never invoke it. On line 10 is when we actually invoke logs a message. And on line 5 there, notice how logs a message, it takes in a parameter called message. On line 6, that's something that I wrote there just so we can be clear. But on line 6, and I put as a comment, line 6 basically says, hey, by the time we reach line 6, that parameter is basically the same as us kind of manually creating a variable called message and setting it equal to whatever was passed in. In this case, let me just change this really quick so that we can do this. Okay. So in this example here, when I call logs a message, notice how what I'm doing is I'm passing in act locally, right? And so on line 6, that's the same, actually, so this happens on line 5. I just wrote it out on line 6. On line 5, when it takes in a variable called message, that's the same as us creating a variable called message and setting it equal to the string act locally. And on line 7, when we console log out the message, it's basically us console logging out the parameter. So, and this is something that it's kind of tricky and sometimes people forget about it. But just don't forget that parameters are also variables and that they are scoped to the same scope or to the function scope that they are located in as well. So now if we kind of want to just do a few examples of scope to kind of get an idea of how tricky it can be, right? Here, if I was to walk through the order of operations, on line 2, we have this variable called global var, where we set equal to the string global. We can skip lines 4 through 12 for now because we're creating a variable but not running it. On line 14 is when we actually run the variable, the function called outer. And so that takes me back to line 4, then line 5, line 7 through 10, I'm creating a function called inner. On line 11 is when I actually run that function inner. And then I create a variable called inner var, and on line 9, I console log out global var, outer var, and inner var. So if I step through each one of those, right, on line 9, when I console log out global var, what JavaScript's first going to do is to say, okay, great, is there a variable called global var in your local scope? And the local scope for line 9 is the function that line is in. So it's going to look in the scope of the inner function between line 7 through 10 and say, hey, do you have a global var? And the answer is no, I do not. So then it will say, okay, great, let's look in your what we call the parent scope, right? Let's look in the scope of the function that you're in. And by your, I mean the inner function. So the inner function is located inside the outer function scope, which exists between lines 4 through 12. And so now what JavaScript asks is, great, does a variable called global var exist in between lines 4 through 12? And the answer is no. So then it'll say, okay, great, how about your parent scope, right? How about the parent scope of the outer function? The outer function really has no quote-unquote parent, or you can say that the parent is the page or the global window. And so that's why when on line 9, then after not finding the variable global var in both inner and outer, it will go outside of the outer function and goes between lines 1 through 14 and say, hey, do you have a variable called global var? And the answer is yes, we do. We created it on line 2. And so that's where we get global var from on line 9, right? The global var comes from line 2. Then when we look for outer var, we do the same exact process. Is outer var inside the inner function between lines 7 through 10? It's not. Is it in the outer function between lines 4 through 11? And the answer is yes, it is. It's there on line 5. And so that's the value of outer var that we use. And then last but not least, inner var exists on line 8. And when we look at our own local scope, we find the value called inner var. And so when we print it out, it prints out pretty straightforward. And so this is just the idea of scope, is that it's a highly logical process, and the main crux behind it is just where do I look for the variables I'm trying to use, right? Am I looking in my own scope, or do I need to kind of go outside more and more? And if so, what's the order in which I do so? Here's another example of this idea of kind of what happens when we have multiple variables are named the same exact thing. On line 2, we have a variable called collision. On line 4, be careful here, the outer function takes in a parameter called collision. And then last but not least, inside the outer function, we have the inner function, and the inner function also creates its own variable called collision and set equal to inner. So on line 10, when I console log out collision, it will say, great, does the variable collision exist in your own inner scope between lines 6 through 9? And the answer is yes, it does. And the value of that is inner. But if I was to do another example now where on line 7, what if I don't create this variable called collision inside the inner function? Well, then where does it look for the variable called collision? Because on line 7, because it doesn't find it between lines 6 through 8, it will look in the parent of that function, which is the outer function, and it will say, great, do you have a variable called collision? And the answer is yes, we do. It's one of the parameters, and the value of that parameter is whatever was passed in to invoke the outer function. In this case, we see that the outer function was invoked with the string outer on line 12, and so therefore collision becomes the string outer. And then last but not least, what if collision only is defined at one place on this page, but it's on the global scope? Then, even though we don't see it, behind the scenes, JavaScript will look in the inner function, not find it. It'll look in the outer function, not find it. And then finally, it'll look on the global scope and find the variable collision and print that out. So this is just this idea that, once again, remember that the inner function, and here I say it both in terms of conceptual and also literally, because that's what we call the inner function. Functions can look in the scope of its parent functions, right? So what function am I in? But it cannot look inside the scope of other functions, right? So inner can look inside the scope of outer because inner is inside outer, right? But the outer function cannot look inside the scope of the inner function. On line 11 there, notice how when I have a console log out inner var, what JavaScript does is say, okay, great, does the variable inner var exist in your own scope, right? Which is between lines 3 through 12. At that point, outer var can look in its own scope, it can look in its parent scope, it can kind of gradually look more and more outwards. But because it is not a part of the inner function, right? The inner function it exists inside the outer function, but it isn't a part of it. And because it's not inside of the inner function, it cannot go into line 7 and 8 to look for the variable inner var. And so because it can't do that, then when we try to look for inner var, we're going to look in our own scope, not find it. We're going to look on the global scope, not find it. And therefore, it's going to trigger the computer to give us back a reference error. And this is just another example of how on line 9 there, once again, just to be careful, when we try to print out inner var, we see that we create it inside the inner function. When we try to print out outer var, we still look in our own scope first, and because our own scope has outer var as a parameter, that's what we print out. And notice how the parameter outer var it assumes a value of whatever we invoked inner function with, and we invoked the inner function on line 11. But notice how we didn't pass anything into the inner function on line 11. And so this is another kind of quirk, if you will, or another rule of JavaScript really, which is that if I invoke a function that's expecting an argument and I don't give it any value, the function is not going to break, but it's automatically going to take whatever value I give it and assign it to or whatever variable the parameter is, and it's going to assign it the value of undefined. And so that's why on line 9, when I console log out outer var and inner var, the outer var variable is printed out as undefined, because on line 11, when I invoke the inner function, I didn't pass in any value, and so therefore outer var assumes the value of undefined. Okay, so far we've talked about scope purely from the idea of function. So I have a function and there's another function, and that's the order in which I look at it. But really, one of the things that kind of ES6 in particular has made a really big push towards is the idea that any set of curly braces, whether it be for a function or an if block or a for loop or anything else, they actually set the same kind of scope, right? And so in line 4 here, right, between lines 4 through 7, I have my open and close curly braces that set the block for these variables. And so because I created this variable called block on line 5 inside this if statement, that just means, hey, that variable block is confined to the scope of the nearest set of curly braces, and it can only be used between lines 4 through 7. So on line 9, when I try to print out block, it says, well, there's nothing on my own scope, and I can't look inside the scope of any any curly braces or any scope that I'm not a part of. So on line 9, we can't look for block inside of lines 4 through 7, and that's why we get a reference error of block is not defined. And so just to kind of clarify, I don't want to spend too much time on this because I feel like this potentially makes it more confusing. Before ES6, when the people declare variables, they use this keyword called var, var. And the main difference between the var keyword and the let keyword that we see more commonly now in post ES6 JavaScript is just that let respects all curly braces, whether it be coming from an if statement or a for loop or a function, whereas var only recognizes scope within the context of a function, right? So in this case, in my if statement, if I create a variable with var block equals Jenny from the, and on line 8 I try to access block, well, var takes the variable block. It says where's my nearest function scope, and say, oh, I'm not in a function, technically speaking, I'm only in an if block. It actually attaches it to the global scope, and so that's why on line 8 when I try to print out block, I actually get back the valid value that I created inside the if statement. Right. So if you ever do find yourself kind of wondering what the difference between var and let is, it's just the idea that when a variable is created with let, it respects the nearest set of curly braces that it's in, whether it be an if statement or a for loop or a function scope, whereas a var keyword will only respect the nearest function scope. Yes, questions?
So was let created pretty much just to allow this block scope? Did it exist before or no?
No, it was created for this idea of a block scope, and it was really created to make the code kind of more precise.
Also, David, can you go back just 2 slides?
This one?
Yeah, this is the one.
Sure.
All right, so if you were to create that function inner
Yep.
function outside of function outer,
Yep.
would function outer still be able to call inner variable?
So if I move line 11 to line 13, for example?
No, let's say you take the entire function that's written between 7 and 10,
Yep.
place it outside of the function, but then call that function inside of function outer.
Yep.
Would it still be able to contact those variables?
Yeah, that would be fine, right? Because when it looks for the inner function or the inner variable, really, right, it doesn't quite know what function just yet. When it looks for the inner variable, it will look in its own scope first, not find it, and it will look in its look on the global scope, and the function inner will be on the global scope at that point.
Okay.
Yeah.
I thought I had read that let was like a more temporary way to declare a variable. Was that just another way of referring to this scope issue?
Yeah, temporary means that you can kind of you're more limited where you can access it. So temporary doesn't mean timing. It actually means more like location. And so if I go back to this here, temporary in this case just means temporary means I can only use it on lines 5 and 6, and after line 7, really, I kind of lose access to this variable block. Whereas if I was to use var instead here, I'm actually able to access this variable block anywhere on this page.
So even in spite of ES6, there's still moments when var would be preferable. It's just now you have the ability to use let.
Yeah. So quite honestly, I've not come across any. So if you Google or if you search times to use var over let, you'll have a bunch of people kind of give you kind of very, very, very specific nuanced rare cases in which var might be useful. But in general, let should be what you use by default. And it will cover certainly everything that we do in this curriculum. And I venture to guess it will cover 99.99% of real world use cases too. I just haven't found a really great example of time in which you could only use var and not let.
Just one more thing real quick. I was wondering, so the even though it has curly braces, the if statement is just a statement. It's not a function at all.
It's not a function. Nope. Yep. Yeah, curly braces don't mean function. In this case, it just means scope. And so the if statement has its own scope. If there's a function, the function will have its own scope. And let respects all curly braces.
Cool. Thank you.
Yep, no problem. Any other questions? All right then, let me just keep going. So the last thing we'll talk about is this idea of a function declaration versus function expression. More importantly, we'll use it will kind of come back to the one of the kind of terms I mentioned in the very first slide. This idea of hoisting. So online, so what we see on this page may seem very counter to at first. On line four, we see us invoking this function, will this work, right? And we invoke it. And on line 6, we actually create this function, which just console logs out yes. Now, when we run this, your first intuition might be, well, it doesn't work because when we get to line 4, the will this work function has not been defined yet. And like that's true, but it also kind of just makes us consider a little more deeply how does JavaScript actually read the code on this page. And the short answer is, and this is not the best, this is a very kind of overly simplified example, but I think it kind of gets a point across, is you can almost think of JavaScript as reading every piece of code twice. The first time it reads it, it kind of scans through the page and tries to figure out what's available and what's not available. And the second time, it'll actually run each piece of code. And so the reason why the reason why where hoisting comes into this is you can think of it as hoist means to raise up. And so when JavaScript goes through the first pass, or when JavaScript goes through the first pass of the code, what it's really doing is it's kind of raising up all the things on the page that exists. And then on the second run through or the second read through, it actually executes those things. And so for the code on this page, the reason why this sequence really works is because on the first run through, on line 6 there, what it encounters is this function declaration, right? We're creating this function called will this work, and on the first walkthrough or the first run through, it will actually hoist this function to the very top of the page, right? It won't run line 4, right? Because line 4 is an execution. But on line 6, because we're just creating a variable, it will actually create that function or create that variable for us, hoist it up to the top of the page, and then on the second run through is when it will actually start invoking the functions. And by the time it gets to line 4 on the second run through, it already hoisted the function will this work on the first run through. And so when it invokes it, all it does is console logs out yes. So a little bit of a tricky concept, and something that I would encourage you not to dwell on necessarily too much. Because the idea here is just that when you create a function in this way with the function keyword, all it really does is it just kind of enables you to be able to use this function at any point, at any location on the page. So if I do another example, right, this is something called function expression. And even though in this case we are also using the variable will this work and we're creating a function, notice how here, rather than doing the function keyword, what we're really doing is we're creating a variable called will this work, and we're assigning it the value of a function. And so we call this a function expression. And this is actually a little bit different than the previous one, because what happens is on the first run through of this, sorry, someone typing in the background right now? I think let's go on mute so people can hear. Thank you. So what happens here is on the first run through of this code, what the hoisting does is it actually just raises up and acknowledges that we've created a variable called will this work on line 6. But it does not assign the value, because assigning a value to a variable is an execution, and that's being done on the second run through. And so what happens here is, and this is actually pretty interesting, we will get an error. But on the first run through, what hoisting does is it says, great, there's this variable called will this work. What's the value? I don't know yet. All right, great, I'm done the first run through. On the second run through, it will say, great, on line 4, I'm trying to invoke will this work. And so when it tries to invoke will this work, it actually throws an error But the error is not that, well, this work does not exist. The error is that, well, this work exists, but it's not a function because we haven't assigned it a value yet. And just kind of, FYI, during this kind of almost purgatory period in which a variable is created but not assigned a value, by default, the value of that variable is undefined. And so in this case, what we're really doing on line 4 is we were trying to invoke undefined. And JavaScript throws an error. You're saying type error, well, this work is not a function. It's actually undefined, and so you cannot invoke it. And so another question that's very commonly asked is, like, well, when would I ever use, function expression over declaration? It can sound like it's more limited. And I would say that in 99.99% of the cases, using function declaration is perfectly fine because it is more flexible and it kind of lets you do what you need to do. Once again, there might be a very, very rare edge case in which function expression is preferred, but in my experience, and definitely for the purposes of this curriculum, it's not necessary. Sorry, I just realized that I have a bunch of messages here in case. Okay.
I have a quick question about
Yep.
that expression versus declaration thing.
Yep.
I can't really remember the finer points of it, but that was one of the things that I struggled with in the pre-coursework function exercises.
Mhm.
Because, in each video we've sort of been given a set of tools to execute like we've been taught, and then we were supposed to do the homework assignments.
Mhm.
Then in the solution videos, I ended up sort of going down a rabbit hole trying to understand that declaration versus expression thing, because I found that the solution ones kind of went over, I forget which of your colleagues was recording it. I can't remember his name, but I mean, they were very elegant, his solutions, but they were solutions that I never would have quite, it was still interesting to see them, but they didn't illustrate exactly how to do it with the tools we already had. They were how you might do it as a experienced JavaScript developer. So anyway, I sort of ran into that whole function expression declaration thing. I don't know.
Anything they did with function declaration, you should be able to do with a function expression, and vice versa. It's the difference between function declaration and expression kind of is that it kind of plays around with this quote unquote priority level of the code or of the functions that you're dealing with. It doesn't change the performance or the functionality of the functions. And so, and I'm assuming it probably is either Ellie or David who probably did that video. If you see them do something kind of very fancy with declaration, I can't imagine a scenario in which if you change that to an expression or vice versa, that function would either do anything different or not work. So I guess just to be clear, are you saying that that they did it with expression and you tried doing it with function with declaration and then it ended up not working?
No, I was just saying that it was like it was interesting, but it was many steps ahead of what I would have thought of in terms of solving that problem with the knowledge that we had based on the videos.
Right, but I guess just so I'm clear, is like what's the role of function declaration versus function expression in that confusion?
Mostly it just reminded me of it, but I did end up doing a lot of reading about that because I didn't know how to make heads or tails of how they were thinking through the solution, and I couldn't come up with a solution for some of them at first, so I wanted to figure out, well, how they do it, and then I was down this whole road. Anyway, just reminded me mainly, but yes, she said it more concisely than I.
Yeah, I mean, and totally, and sorry, and so the reason I was pressing on it was not to be difficult, but really I think I just want to kind of make sure I understood what the problem was, right? It sounded like there were kind of two things. One is just that kind of in the hands of a more experienced programmer, right? Like the way they think about the solution may seem a lot more elegant or a lot more straightforward, and that's definitely very common, and every person's going to experience that. But I just want to make sure that that had nothing to do necessarily with a direct application of function expression versus declaration. It sounds like those two issues were not intertwined. And in general, I would say that function declaration and expression it's a nuance. It doesn't change the performance or the functionality in either scenario, so that should not have been the issue. But the other thing I'll just say about kind of this idea that the solution video solutions look really elegant and better, and you're like, wow, like how did they come with that? I could never think of that myself. It's the unfortunate truth is that it just takes time and experience. And at this stage, it's actually a lot more important that you are able to kind of get a answer, even if it's not the most elegant, because the optimization and the solution kind of comes with time. And I promise you, like every developer goes through the same experience. The another analogy that I like to think about, it's almost like like if you think of like a sport like basketball, right? Like I can teach you how to dribble a ball. I can teach you, I can teach how to dribble a ball, right? And when you watch a professional player play, they're still dribbling a ball, right? Like they're not doing anything fundamentally different than you, but the way they do it is they can chain together, they can do different kind of tricks and all this stuff. And so even though the fundamental thing of what they're doing is the same as you, like when you put it together, like it just looks like something that's like different, and in a lot of cases like very intimidating because it's so much better, right? I would say like that's the code. That's like a lot has to do with the code here too. Is that the things that we're teaching you and the things that they're doing, if we boil it down to the very basics, it's actually not that much different. Like this idea of loops, this idea of functions, this idea of passing variables back and forth, that's all they're doing too. They're just kind of doing it more elegantly with like a shinier wrapper. But they're like from a functional standpoint, they're not doing anything that's very different, and the elegance and the kind of like the flair will come over time. Yeah. Sorry, there a question? Yeah. If you have a question, just yell it out. Because when I'm in presentation mode, it's hard for me to open the questions on Zoom. So it's probably just easier for whoever has a question right now to just say it out loud. Or not. Okay, so the question is, could it be that we're doing the solution in ES6? Possibly, yeah. ES6, and I'll just give a really quick spiel here. ES6 introduces a lot of shortcuts that make life really easy for us. But once again, there's nothing that we did that we're doing in ES6 that we could not kind of replicate in a pretty straightforward manner in ES5. Like with any of these solutions, if you have any questions around like, oh, hey, like I don't understand how this is doing, or is this interesting in you, definitely let me or one of the fellows know. We're happy to kind of walk you through it. But once again, well, I guess this is my first time talking to you, but usually in the intro lecture, what I always say is that kind of when you're first starting off, like it is so critical, like that you understand kind of what's going on, and you also understand, and then like you understand like the core foundations of what's going on, right? Like one of the things that people always ask about is, well, when I write a function, do I use the arrow syntax or do I use a function keyword? And the answer is it doesn't really matter, especially when you're first starting off, right? When you're first starting off, it matters a lot more that you know what a function is and how to use it. How you create it, like that's a syntax difference, and that's something that can be adjusted very quickly. Now the arrow syntax does have a few other capabilities, but they're also kind of not something that you would use in an introductory course. So I wouldn't stress too much about that. It's just this idea that once you understand the basics, building on top of it is really, really easy. But don't let don't let kind of like the shininess or don't let the shininess or the newness of something kind of make you think that something is much harder than it really is, because it's not, right? It's just the same old fundamental things, but they've just added a few extra conveniences to it. Sorry, did that answer the question or any other questions? Okay. Are there any other questions before I move on? Cool. So the last thing I'll just say then is a few kind of words of warning. Generally speaking, global variables are bad, and in a lot of browsers or environments, if you actually try to use a global variable, the computer might even yell at you or just kind of show it up as an error or a warning of some sort. And the reason why global variables are kind of a bad practice or a faux pas in a lot of ways is just because when you have a global variable, anyone can use it, and more importantly, anyone can change it, right? And so here on line 2, I create this variable called always true. I set it equal to true. On line 4, on line 8, I run this function called don't mind me. And in don't mind me, on line 5 there, what I do is actually change always true to false. So by the time I get to line 10, I actually, even though I'm using always true, which is a global variable, I actually don't have any idea like what the value of always true is because anyone could have played around with it, tweaked it, and modified it. And so therefore that makes that variable very dangerous because you don't know who else has access to it or who else is using it. And really that's kind of the main reason why we have scopes in general, is just to say like, hey, I want to create this variable within these limits so it is only used within these limits, so that I know who has access to it, I know how it's being used, and I can kind of rest assured that no one else no one who should not have access to this variable is able to use it. And so in general, global variables are just kind of a bad practice. So because you never know who else is changing or modifying it. In this case, one way to kind of get around this is to say, hey, and don't mind me if for some reason I want a variable called always true as well. I can always create my own, right? And on line 5, when I create my always true variable there on line 5, remember the like keyword confines that version of always true to only to its nearest scope, which in this case is a don't mind me function scope between lines 4 through 6. And therefore, when I get to line 10, always true is still equal to true because no one else changed, right? So even though this is a way around it, notice how this assumes that the don't mind me function is being responsible and only changing what is supposed to change, which is not a guarantee that we should take for granted. Oh, sorry. And then a few other things is when you have a global variable and we have a global variable we have a global scope with a ton of variables, it's easy for the variables to start kind of overriding one another. So that's also another reason why we kind of want to minimize variables on the global scope. But that's pretty much it, right? So we talked about what scope is, and we talked about the different kinds of scope. So there are the global scope, which is kind of the outermost shell of a block of code. There's functional or local scope, which basically refers to the scope defined by the curly braces assigned to a function. And then there's block scope, which refers to the scope defined by the curly braces assigned to anything else, right? It could be an if statement or a for loop, etc. We talked a little bit about functions and hoisting. More specifically, that if you use function declaration, then that function is hoisted to the top. Whereas if you use function expression, then that function is not hoisted to the top, and therefore you cannot use it anywhere on the page. You will only use it after the value has been assigned. And then lastly, we just kind of did a quick note on why global variable scopes are very bad. It's just because it's not safe, because anyone can access or modify those variables. Okay, so any questions?